first one says circle the repeating decimal. Somebody tell me what a repeating decimal is. Kendall. Yeah, the same numbers go on and on forever. And mathematicians don't like to have to write out numbers forever. They're very lazy, so they're always coming up with shortcuts. Okay, so their shortcut is called bar notation. And that bar tells you exactly which numbers are repeating. Okay, so when it says circle the repeating decimals, you only have two to choose from here. You have this one right here, because there's the bar. And then you see the bar over the 2, which means in life, this 2 would keep going like this. On and on and on and on. So that one is repeating. Then digits has this weird thing which I do not like because this is not really mathematical. When they do this dot, 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 that means that the number is continuing on. But what I don't like about digits is how do you know which number's continuing? Do you know that it's 2525? Do you know that it's 2555? So I don't like when they note it like this. But I think what they're trying to get at here is that they're trying to show you that it doesn't stop, which we're going to use that today when we talk about terminating decimals. Okay, so if you circled that one, great. If you didn't, that's fine too. I don't like the way they do that. All right, questions on how you find repeating decimals? You can identify them. Okay, next part. How do you change 1/13 into a decimal? 2 people, 3 people. Okay. Yes, so we've talked about a fraction bar is a fancy way of saying divide by, right? Because we've talked about complex fractions where we've had fractions over fractions. So this just means you're going to divide. So 1 divided by 13. I'm going to go to my calculator because I said you do not have to use long division. Okay, and I get this big number. Okay, so when I look at this one, I need to see, is it repeating? Do you see it repeating? Yes. So it goes, let's see, let's write this one down then. So I'm getting 0.0769, then it goes 2, 3, is that where it stops? Or then it goes 07 again. You guys see that? I don't know if this will let me, oh, it won't let me write. So here's 076923, 076923, 076923. So this is what's repeating, and you've got to have the bar notation of that entire thing because that's what's repeating. Can you see it? I like the green calculators on your computers because they give you a bigger window to look at to see the repeating. Does that make sense, or do you want me to explain it some more? Is that okay? All right, let's look at the next one. How can I turn 6 and 5/12 into a decimal? Kendall?
It's pretty much the same thing. Except 6 is a whole. This 6
Perfect. It's the exact same thing. You already know that 6 is the whole, so you can just leave it like this and just divide the 5 divided by 12. So now I'm going to take 5 and divide by 12, and I get that number. Okay, so then I'm going to write 6.41, and then a 6, and only the 6 gets the bar notation because that's the only number that's repeating. And some of you guys, if you're using like the little blue calculators, it might have like a 7 at the very end up here. What's your calculator doing? It's rounding. So you have to be smarter than your calculator. You have to understand that you really don't keep that 7 back there, that it's all 6's repeating. Okay? Is that making sense? Yes. Of course you could, and you would get the same answer, right? So that is fine. It's just a lot more work and a lot more chances for us to make silly errors. So I like to just keep that whole number. Yes. Because they have to leave something to the humans. Otherwise, they would take over the world, the robots. You guys are fun this morning. All right. Let's see if I can get to, was there another number over here? No, so it's just those 3? Okay, so electrician cuts away a long section of drywall to repair something. He has scraps, and he wants to repair the hole. Circle the drywall that is large enough for the hole. I can't see what's the, oh, 7.2. Okay, the 7.2-inch hole. All right, so in life, in order to compare fractions, either they all have to have common denominators, so I can tell what they are, or I I gotta change them all to decimals. Most of the time in life, we'll change them to decimals because decimals are easier than fractions. Agreed? Okay, so we're gonna divide each of these. So I'm gonna keep the 7 here, and I'm gonna have 7 point, I'm gonna take 2 divided by 13. So 2 divided by 13 is, oh, another big long number. Okay, so this is what? 1, 5, I'm gonna put 1, 5, 3, 8. How many numbers do I really need if I'm comparing it to this, by the way? I really only need to the 10th place. Okay? Is this one going to be big enough for this one? No. Well, I know you have to move the decimal over 2, right? What would this be? This would be 7.15. This is 7.2. Is it going to be close? It's going to be close, but it's not big enough, right? Okay, so that one's not going to work. Okay, so let's try the next one. Okay, we're going to take 3 divided by 14. 3 divided by 14. And that is 0.21. Is that one going to be big enough? Yes, because I only need 7.2. That's like $7.20. This is $7.21. Okay, now let's check the last one. So I'm going to take 5 divided by 21. So 5 divided by 21. And I get 238. What do you think? Yeah, that's big enough because I only need 5.2. And that one would be big enough also. Okay, questions on that? Okay, today's lesson piggybacks off this. So we'll review this even more today as we're talking about our new stuff. All right. All right, learning goal today, you're going to understand the difference between terminating and repeating. So it's really, to me, I think this is pretty easy to do today. All right, so a terminating decimal just means the decimal stops. Okay, lots of decimals in the world stop. Okay, all the money that we deal with, $10.34, that stops. Okay, there's nothing after it. If I say, I don't know, what else could have a terminating decimal in real life? Here's a good one. Prices. Grade point average for a lot of you will terminate. Sometimes what happens though, have you seen it go repeating? Sometimes it will repeat. So it just stops. That's it. And everything left will be zeros. Okay? So if I have 75 cents, then all of these place values are zeros. And zeros can go on forever, but zeros don't change the number. Okay? All right. So that's a terminating decimal. So the next one, it wants you to drag each of these into the correct slots here. All right. So drag each decimal or fraction equivalent to the correct bucket. So terminates, it does not terminate. So what about this number? Would that terminate or not terminate? Does it stop? So if it stops, what's it? It terminates. So this would be 0.3. It stops. It's done. It doesn't go anywhere else. All that's left is zeros. Okay, all right. Let's look at this number. Where does that go? Terminates. It stops, right? There's nothing else there, so it terminates. Okay. Let's see. What about that one? 1.72 with that bar notation. Very good. What's that one called then? It's called repeating. Very good. Okay. All right. How would I figure out where 1/3 is going to go? You have to divide it. So I'm going to come over here. Does anybody know what it is before I divide it? That's one that we usually memorize. It's a pretty easy one. So this one is a terminate or non-terminate? This one does not terminate. It goes on forever, right? How would I could write it like this, or I could write it like, or 0. I can put 0.3 and write it like that. Yep, either way. Okay, let's see. What if could you guys do the next ones and put them up there? Okay. All right, so when I look at this one right here would not terminate, right? Because it has the ... even though I don't like the way they put that on there. This one would not terminate. It would go on. What about 1/6? Does not. Okay, so that's what it looks like. So it does not. So we're going to put 1/6 here. All right, this one stops. It terminates. 41.75. This one stops. It terminates, so negative 9.875. And what about 1/8? It does not either. Oh, wait, are you sure? Yeah, it does. Yeah, it does. So we're going to put 1/8 over here because that's the same thing as 0.125. Okay? Any questions about just picking which box they go in? You guys understand that? This means yes. This means no. All right. Let's go ahead and let you guys work through those. Make sure you get that, and then we'll go to the next part. All right, so which ones are terminating? This one would be terminating, right? This one would be terminating. Even this one would be terminating because they stop, all right? Now, the next one, the number 3 would not be because it has the dot, 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 which I hate the way they do that. All right, is 407 a terminating decimal? This is a trick question. What do you think? Does it stop? Yes. Okay, and if you say, but there wasn't a decimal, where's the decimal point? Where? It's at the end. It would be right here. So that would be like $407. That terminates. That stops. Okay, so even though it says terminating decimal, that still works. All right. Okay, so can you do this like if you get a real life problem? So, get this so I can see it. A recipe for a 6-foot sub calls for 3 7/8 pounds of sliced deli meats. If you want to get the exact amount from the deli counter, what decimal should the digital scale show? Can you tell me how to do it?
So the 3 is a whole number, so 3.0, and then you divide 7 by 5.
Good. And I would get 875. Is this a terminating decimal? Yes. Yes, that's a terminating decimal. Okay, and I mean, I see people go to the meat counter all the time. They're like, I need 3/4 of a pound. And then the scale is all digital. So you have to know how to convert those back and forth. All right. Okay, last thing I want you to do just to make sure you understand everything from yesterday and everything from today, go ahead and complete this slide, and then we'll check it and make sure you're on the right track.